Serge has become a friend of mine recently. He was introduced to me by one of our strategic consultants and software suppliers. He has a doctorate in nanorobotics, but for some reason I have yet to fathom, he became interested in the issue of built environment and has been a leader in the concept of the bioclimatic facade. In fact, he's organized the bioclimatic facade initiatives in Europe and is now at this point in time working on computational systems which allow our buildings to be responsive and to change based upon what's going on outside and inside the building. So it becomes truly a dynamic living system. And in fact, what he's after at this point in time is really the concept of a living model. A simulation that is up and running with the building, predicting what's going on in the building based upon past experience, future experience, what's going on in the climate, what are the weather patterns, how do we set up and tune the building so we can use the least possible energy. So for whatever reason, he decided that sustainability in the building industry was his focus. He is speaking in his second tongue. Please listen carefully and help me welcome, and see if I can get this right, Serge Neuman.
Thank you. It's working as it seems to work. So the first presentation is going to be for 15 minutes about simulation tools at the early design phases. And I will start actually with an advertising which was aired on the British television in 1986. It's a way for me to give you some other accents than the French one. This is going to be a British one. But it's also a way for me to make my point regarding the first part of this presentation about the risk we have when we design a building and we are at the earliest phases. After, I will speak a little bit about DaS06 strategy, and I will finish this presentation with the third part about how the passive strategy challenge all the simulation tools, especially at these early design phases. So let's start. So I found this had quite interesting when we speak about risk. I don't really have time to go in all the data, so I'm going directly to the conclusion. And the conclusion is to avoid risk. We have to have an holistic view, and we have to have a perfect knowledge and understanding of what's going on. But except if you are a Sheldon Cooper, you cannot say that you can understand everything, and you cannot say that you have an holistic view. That's why the building industry came with this idea of IPD, meaning that we bring all together a lot of experts who are going to be, as a group, being able to have the holistic view and the perfect understanding. And the goal, of course, is to avoid this kind of stuff, not having a stairs going directly to the wall. But the question I have regarding this is when you put all together a lot of experts, knowing that each of them has to work for them, and each of them might disagree with another one because he knows that the option taken might make his life very miserable in 2 or 3 times in the timeline of the building. What's going on? And with the IPD, really, we are in this kind of situation, which is what is well known, actually, as the decision by committee, where people are not trying to go in the right direction because that's the right thing to do, but people are trying to go in one direction because actually it's the easiest way for them. And in the building industry, the worst thing that can happen is at the end, maybe we can have a green path. Our building can be green, but it will be a very, very narrow green path. And the goal of the simulation tools is definitely to avoid this kind of stuff. So it can be done if at the early stages of the building design, we can really have a kind of simulation tools that allow everybody to make simulation. That's why we need them to be very simple. To allow people also to be convincing, because you will have to explain why this is the right decision, even if it makes the investor to have to invest more, even if it makes another expert to work more on his part, or maybe to go over budget to be able to reach his objectives. But we also have to have tools which are not only simple, not only convincing, but also not misleading. Because when we are really at the earliest phases, when the champ des possibles, so all the options possible, the universe of all the options are still there, it's very, very easy to be misled and go in the wrong direction and finish in something like this. So that was for the generic specification of what we need at the earliest design phases. Now it's time for me to speak a little more about the passive strategy. For those who are not in the building industry, passive strategy is all this solution you can have to use the natural and free element and energy that are around the building and within the building in order to take benefit on it in their natural state. So you don't transform them, but you use them to create a safe, healthy, and comfortable interior environment. That's a good definition, but the question you might have is, does it work or not? If it's so good, why is, for example, in the US, the actuary was coming from the active solution, so not the passive, the other one, would decide what is the regulation for buildings. Well, to answer this one, I think I can make an analogy with food. I have a French accent, I'm French, so somewhere I have to speak about food. If you look at this, your mother, your grandmother, or your grandmother had only one cookbook, and this cookbook was the one from the family. It was given generation to generation. And they didn't have a lot of tools. Today, there's plenty of cookbooks, and there are plenty of tools. In building industry is the same. Before, architects was learning their job thanks to other architects in studio. They're working on project, and they were learning their way like this. Today, there's a lot of cookbook called LEED, CASB, BREEAM, Green Star, HKE. I can name plenty of them. And there's a lot of tools. On the DOE website, there's 406 software listed to help engineers and architects to design well a building. But the conclusion in the building industry is a little bit the same that in the food. Meaning that a good meal is still a good meal, and a good building is still a good building. It doesn't really matter if you know how to do it or what tool you use. It's not what makes a good meal, it's not the tools. It's really something else. So as I said, that's something which also can be done or seen in the building industry. If we think about building before 1850, roughly, when there wasn't any electricity, when actually energy was very, very, very expensive. When you think about all this building, so somewhere is sci-fi here in the US, but when you speak from Europe, we have plenty of them, so we can really look at them and watch them. When you see this building, most of the building is only structure and architecture. They did not have anything else than passive solution. And to tell you everything, a lot of these buildings are still there today because architects were quite motivated to make a good building. The king, if he wasn't happy, would only kill the architect, which is quite a good motivation times to time. So that was before the industrial era. But with the industrial era came electricity. And with electricity came something new in the building industry, which is architects started to explore shapes, volume, and started to forget what is a building. And they asked the engineers to come and apply their magic somewhere. So the electricity, the air conditioning system, the heating system. So this shape, this volume is livable. So people can live into it. And that's today business as usual. What a lot of firms, what a lot of regulations start to do, and actually all the regulation in Europe due to the European Energy Performance Building Directive is asking today is to have a more balanced situation. So they ask the architect to go back to architecture, to use all the passive solution possible, so the building by itself is energy efficient. That's the goal. And therefore, as I'm still in the food metaphor, I'm coming with the recipe for a well-designed building, and actually a green building. So first question is, what is the definition of green building? And somewhere, my definition at least, is a building where the interior environmental quality is the best possible for the smallest environmental footprint possible. So that's just a ratio. Regarding Interior environmental quality is quite complex, and actually it will be my second lecture. Regarding environmental footprint, it's quite easy also. It's a question of not introducing on Earth something that does exist if you don't spoil it from someone else. Typical example is, why should I have this artificial lighting which create photons that come to us when actually all around this building there's 3 photons coming from the sun? And that's why passive strategies are so important. And that's why when you think about making a building, designing a building, you always have to think, should I need a new building? Yes, no. If no, take one existing if nobody does anything with it. If yes, apply all the passive strategy possible. And of course, because the passive strategies are limited somewhere by the fact that they are linked to the climate and the weather, you will have sometimes the need of active solution, meaning the need of other source of energy to be turned into something else, typically light. And therefore, you have to use first the mixed mode or the active one. So mixed mode is the fact of using 3 elements around you and improving them one way or another thanks to the active solution. Night cooling, to take something that you might know, is a typical example of it. But all this will require energy, and because they require energy, you will have to provide this energy. So first, use renewable energy, but produce on site. I don't really have time to go in details why it's so wrong not to use renewable energy that's not produced on site, but it's very, very wrong. And after, because sun is not always there, so PV is not working 24 hours a day, you will have to use the plugged energy. So yes, the recipe is quite simple, and yes, it's working well. This is an example of what you can see on the LWL. If you go to the EPA website, you will see a lot of examples, and the different tables are coming actually from the city of Vancouver. It's just to not take into account everything which is written in Europe, because there's a lot of other material in Europe. So that was for passive strategy. Now, I have to speak about simulation tools and passive strategy. And to do that, I have to make a point regarding the fact that there are 3 families of passive strategy. The first one is the one everybody thinks about. That's the fixed passive strategy. Fixed overhang, insulation, fixed insulation. This one, nobody never challenged me on that. I do understand that. But when I start to speak about operable passive strategy, people start to have some issue, because for them, passive means no energy. So no energy means it should be static. But actually, if you think about what is an operable window, it's something that you move. So there you have energy. But it's not the movement that creates the natural ventilation. The movement is just there to put the system in the configuration where the passive effect apply. So really, you don't have energy in this passive strategy. Or otherwise, you use your windows like a fan, and it's not a very good propeller to use the window like this. So operable passive strategy does exist, and if there are strategy that can be decided by human beings, it means that one way or another, I can have a computer doing this. And therefore, I have my third family, which is dynamic passive strategy, and this time is the building management system, the building automation system, who decide in which direction, on which position all the system should be, on which kind of passive strategy should be applied for the benefits of the building itself when there's nobody inside it, or for the benefits of people inside the building. So now, what does it mean for simulation tools? Well, first, because we're speaking about passive strategy, it means that we need to have a tool able to know what is building physics and also knows what is the fuel of building physics and passive strategy, meaning the climate, the weather, and the internal load. And as I said, it comes with the architecture, and we have a simulation tool for fixed solution. There's plenty of them. That's not an issue. It does exist. So here we are set. Where it's become a little more difficult is when we start to speak about operable and dynamic strategy. Because, as said, it's not the movement which makes the passive strategy. I can actually make simulation of different fixed solutions, and I will have just to gather all together the result to have the result of the simulation for the passive, operable passive strategy or for the dynamic passive strategy. But where it starts to be very difficult, there's not a lot of tools are able to have an architecture which is not fixed, which means that you have to go for simulation, make one simulation, for example, until the 12th of April, stop it at 11 o'clock, and run a full new simulation where you say that the condition for 10 to 11 o'clock in this building is the result of the previous simulation. That's very, very time-consuming. It's not working so well. But in fact, the situation is somewhere worse, because in operable passive strategy, it's a human being who will decide where we go, which fixed solution is applied when. So we need to model the human behavior. And there's a lot of stuff to be done. There's already a lot of different study which has been done. The actuary has given a lot of model regarding the thermal part of the comfort for human beings. The visual part is currently under process. There are people working on this, but we already have some results. But still, we know that human beings are more complex than this. It's not only about comfort. It's also about mode. It's also about a lot of other stuff going around. So we need to have better model of people. And if I'm speaking about dynamic passive strategy, I have this first issue, which is a lot of automation systems for buildings have a human beings override. So you have a manual override, which means that if I want to make a simulation of a dynamic passive strategy, I will have one way or another to model human beings. But let's say that you don't want to do that. You just look at the building when it's on its own, and you don't let people to override the system, and therefore have two other difficulties. One is have to know what is the automation law for this building. And I do recall you, we are at the earliest phase of the building, which means that we don't really know actually what is the building in at this time. So it's quite complex at this time also to know what are going to be the automation law. And the second challenge is the building automation system itself, because they have sensors, because they have actuators. These sensors and actuators are just as filter. So the figures coming from the simulation are not used immediately by the system, and the system won't react immediately. And this also has to be taken into account if you want to make dynamic passive solution simulation. So it's going to be time for me to go for a conclusion, which means that I have 3 slides remaining. This first one, regarding dynamic passive strategy. That's a job made by Lawrence Berkeley National Laboratory, a very interesting one, which works quite well, but doesn't exist right now for the earliest design phases. So we need it at the earliest design phases. But just to tell it, what is it very, very quickly? It's about making a simulation just as you have flight simulators in the aerospatial industry. So it means that you have a simulation of the building going into the real hardware that's going to be used by the building and going back after to the simulation. So we have a loop like this, and we know how the building is going to evolve. And I dream to see something like this for the earliest phases, because it will help a lot of people to do what they have to do. Other point for my conclusion is all about these simulation tools. You have to realize that actually it's somewhere needed by the industry, but now it's mandatory. In Europe, I said, we have the European Energy Performance Building Directive, and this Performance Building Directive asks for simulation to prove that your building is really meeting the energy goals or energy savings that we ask him to have. And now the new generation coming, for example, for France, is the RT 2012, so Thermal Regulation 2012, is asking for a coefficient called the bioclimatic coefficient that gives you what is the energy performance of your building based only on the passive strategy. So you consider that all the active strategies are 100% efficient, and you look what is the consumption of the building. It gives you a figure. You have to have this figure below threshold, meaning that you have to do well already with all the passive strategy. But when you give this figure, and you have to give it at the earliest phases of your design, you have to give it to I'm looking for the word, sorry. You have to give it to the people, to the politician. When you give it, you cannot come back on it. Meaning that when you go after for the design of your building, really, so when you ask the permit, you have to give this figure, and you cannot come after with another design where the figure is higher than this. So you really have to commit with everything like this. So there's a lot of challenge there, and a lot of them are going to come very quickly on the market because politicians, at least in Europe, has decided that it should be done like this. And if you read what is late 2012, the proposal for late 2012, you will see that actually in the US also it's coming. So time to wrap up everything. And to finish this presentation, I want to speak about one last thing that simulation tools should provide, especially at the earliest phases. Making or designing green building is not that simple, actually. And really, if we have tools, it should be to help people to do right, and do right quickly, do right at the first time. And so for doing it with building, we have to figure out different way to be sure that people are doing this. I give you the trick I'm usually given to students in architecture or architect when I have to speak with them. I tell them, just imagine that you have to live, or that you will have your child live exactly where the building is, where there's no building. So you have your child, or you are yourself, and you live for 1 year, 1 full year, where the building is going to be built. And you won't have the choice. You will have to stay there, just there. And I'll let you just to pick up which clothes you want. And usually if you do like this, if you think about this, if you want to be dressed, if you wear the building, therefore you start to have really a good approach of what is the right design for the building, how to well design the envelope, and also usually you go for a really very clean green building. Thank you.
A little misleading because Serge is actually giving us a second presentation following on right behind, where the key thinking now isn't so much simulation, but this really, really important issue of these intangibilities. And these intangibilities for us in the architecture world come down to performance, what people are doing in their workplaces, how productive they are, how we can improve their productivity. Very difficult for us to measure, very difficult for us to establish ROI on, but in fact we're beginning to get a lot of good return on investment metrics coming out of healthcare, coming out of schools, coming out of commercial office buildings, and even communities. So, Serge, please carry on.
So, yes, thank you. I think they were thinking that by now you are used with my French accent, so you are able to understand the second part. That's a very interesting theory, actually. Should we really have marketing to sell to people that outside is good? Should we really use marketing to explain to people that we have only one planet and there is no plan B? The International Space Station is roughly 10 people, so we already have to eliminate a lot of people around here to be very sure that we have space for us in there. So do we have to do that? And that's an interesting question. And actually, when you think about it, that's really a good question. Because our civilization is based on the ideas that I do exist if and only if I can be related to a building. Civilization actually comes from the French civiliser. So this one was with a good accent. Civiliser comes from the Latin civitatem. Civitatem means living in the city. It means that you are a citizen. And somewhere tells this notion that if you are not living in the city, so if you are outside the city, therefore you are primitive, you are barbarian, somewhere you are an animal. So the whole humanity built itself on the ideas that we have to be with a building. And that's very disturbing. The topic is about intangible benefits, which is also very disturbing for someone speaking French, because intangible has another meaning than for you in English. But the first intangible benefits I have to ask is today, how many children, how many Mozart, how many Edison, how many Einstein do we lose as humanity because this child is not nearby a building which can allow him to be, to be part of a society. And that's a huge, very huge intangible benefits. And I can go on with this kind of intangible benefits with the Millennium Development Goals, because a lot of them are also linked to the buildings. But still, come back to the topic here. Let's speak about software. There's here a place where the geographic information system can really help us to define this. These kind of tools could allow us to keep track of all these children which are not nearby building, which should help us to think about urbanism another way, should help us to sum up, so to come from a bottom-up approach of all these intangible benefits we can find in buildings and bring them back in a huge amounts of money. So politicians think really about it and put all the regulation we need so it's going down to the building again as regulation and we really have the right building. The example here is actually in French. That was also part of your training. On the left side, which is actually in English, you have a study made by a professor, a French professor called Serge, who is using mathematics called morphomathematics. And he has shown that actually the pattern of the city has a huge impact on the energy performance of building. So it's not only doing whatever you can on the building, it's not enough. You really have to think about the city size on your neighborhood because it will have a huge impact. And therefore, I have a question for people making software or proposal for people making software, especially GIS. Why not having a layer giving you what is the potential in terms of energy savings or what is the potential in terms of lead credits, because I think this one will have a short-term return on invest if you develop this kind of tool. But why not having a layer on your tools, being able to tell, okay, in this position, you have already the possibility of having these amounts of credits. In this one, you won't have, because actually there's another building casting shadows, so you don't need this credit and you don't need this one. If we have such a tool, actually, and we really speak about credits and leads credit, you will say that this layer will speak about passive solution, and they will speak quite a lot about periophilia, and will speak quite a lot about access to nature. And there's something we should agree about. Whatever is your belief, whatever is your faith, whatever is your certitude, there's something we should agree about, I'm quite sure, is the fact that there was no building at the origin of mankind. So building is an invention of man. And building is not our natural environment. So we are not designed, we are not done to live within building when actually today we spend 90% of our time there. So there's a lot of studies showing you that there's a huge impact of having connection to nature, which means also that one of the biggest source of intangible benefits are going to be in the passive zone of the building. So the passive zone of the building is a 6-meter wide zone, let's say 20-foot wide zone, starting from the envelope. And that's where in the building you can still have the benefits of all the passive strategy. After this 20 foot, you have to have passive active solution because you don't have enough energy or enough transmission from the envelope to the building to really rely on passive strategy. And speaking about intangible benefits, a question which is quite usual is where are the office of the executive in your firm? What is the common ground of these offices? And because we spent a lot of money also to attract the best student in university, in our firm, which kind of office or workplace do we propose to them? So we invest a lot of money. It will be a shame to waste all this money just because they don't like the working place. And of course, something that is common to everything is space and intimacy. That's and privacy. That's quite important for our executive because everything inside cannot be spread around the open space. But actually, what is really the common ground is to have access to nature and to have plenty of daylight, which is really not something very smart to be done if you speak about return on invest. First, because there's no reason to do that, either than saying that's the best place and that's where you will attract people and keep people. If we're speaking about energy consumption, first, you have to realize that energy consumption is pocket money. Never trade your salary for less than 200% or the increase of 200 times the energy bill of your desk. Because actually, when you look at the operation cost, your salary is more than 100 times more than what is the energy cost of your office. So energy is not the reason. And whatsoever, the firm pays for the full floor, which means that it doesn't matter if you are nearby the envelope of the building or if you are nearby the core of the building. What does matter, in other hand, is the fact that your productivity is going to be increased. But there again, if we speak about executive directors, there's something which is quite common around the world, is these people, we are not spending a lot of time within our office. We are in a lot of meetings, and therefore we are not so much there where we have this improvement of productivity. Which means that from an economic point of view, really to know who should have this office, I should make a ratio regarding how many time someone else spent at his office, at his desk, over the time I'm spending myself, and doing the same regarding the salary. And if everything else is equal, therefore I will know who has to have this best position. Unfortunately, of course, human beings are more complex than this, so not everything is equal. And now to finish this presentation, actually, I will give you 4 slides remaining. The 2 next one is about a tool that I wish to see one day because I think it will really change the way people will design building. And this tool is about having an optimization of the intangible benefits. To do that, there's 2 ways. One is to make something like SimCity or The Sims. So you will have intelligent artificial intelligence working within your CAD drive, and you will see who is more productive than who if you put his office there or there. And therefore, you will see that the layout of most of our offices are not the best one if we speak about money, about payroll, about return on invest. That's a very interesting one. I think it's very fun. I started to make one with cellular automata, actually. But it took a lot of time to converge. So there's another possibility, and this one could be done right away, because everything exists. This one is about using BIM and having your CAD file providing all the information regarding the building to another tool which has been developed by Professor Lofness at Carnegie Mellon. And this tool is a matrix where you have all the papers from around the world, giving you what is the productivity or what is actually the impact of building, connection to nature, passive strategy has on human. So it's also in terms of Earth, but it's in terms of money and productivity and things like this. So we can really imagine to have a tool which is giving all this information to this matrix, called EVA matrix. This matrix provides you a bunch of papers, scientific paper, telling you in this condition, the return on invest or the productivity was this. Simulation tools came into the competition there. Enter, provide simulation of your building, telling you if you meet the same condition that the one that was displayed in the paper, the one people have seen when they saw the result. And we can have, with being 5D at the end, a return on invest. And something is going to be very, very striking for a lot of people. You will see that we are not speaking about the same amounts of money that we are speaking when we deal with energy savings. We are going to have 1, 2, even sometimes 3 orders of magnitude in terms of money. I was wondering how I will finish this presentation, so I made 3 slides. That's the third one. It's a new paper that can actually provide me with. And it gives you that if we use everything I said, if we really go for bioclimatic architecture, for biophilia, New York, the city of New York, will be able to have savings that more than 2.7 billion US dollars a year. For you to know, it means that 20% of the country around the world has a GDP less than this. It means that 20% of all the countries around the world are not able to create these amounts of money that we are wasting just because we are not designing the building the right way, just because we don't have designed the urbanism on the city the right way. That's my before last slide. Just to say that I was really wondering how I can finish to convince you. And I was starting to make something like just what I show you, to give you comparison regarding how many times or how many days a year an American citizen is working just to pay the energy bill. And how many days, and actually it's 21 for you to know. How many days do you work, or could you be in vacation if passive strategy was applied, if biophilia was applied, if bioclimatic was applied? And I came with a lot of figures around the world, around the presentation, around the slide, and therefore I decided to go another way. I decided to go back to what really is behind all that, and all that behind all that is money. And our society has built itself to generate money. And the fact is that to do that, we only have one planet with limited energy, limited element, and limited resources. And there's someone, I won't be able to recall his name, but someone said that anyone who believes that you can have an infinite growth in a finite world is either a madman or is an economist. Therefore, we know that here there's something wrong already. But actually, we also have to realize that money doesn't exist by itself.
1, 2.
Was the same.
12 volts.
But money doesn't exist by itself. It does exist only because there are human beings. So money by itself doesn't have any value except the one that human beings are using. And the one human beings are able or wishing to give it to it. But if we think about people, we have to go back to what I said before. The fact that we are coming also from Gaia, but we're coming from nature. There's this strong connection. And we know that nature is not always so good to us. We know that regarding everything existing on Earth, we can live only in some part of Earth. And after, we have to use clothes to be able to protect ourselves against some extreme climate regarding what our body is able to support. And because there are some limitations, we have building doing this. But my purpose with this slide is to say, if you think about all that, there's always something which is in the middle of everything, and that's human beings. So human beings are really key. And as soon as we speak and we think about human beings, therefore everything is going the right way, and therefore it does explain why the intangible benefits are giving such big figures at the end of the day. So that's the conclusion from me. Thank you.
Any questions? Come on, I know there's a question.
They're sleeping or commencing, convinced.
I myself have been absolutely amazed. I've been involved in a research project over the last few months looking into this issue of biophilia. How's that? Looking into this issue of biophilia and what it means to us, and many of you may not understand some of the impacts of what Serge was saying, but just take, for example, this bioclimatic zone. He said it's 20 feet from the envelope in. Well, through the modern era, when we had HVAC, our goal was to minimize the skin and maximize the internal space that we could use. We're used to putting up buildings now that are running at a depth of 200, 240 feet. They're 500, 700 feet long. 80% of those people are out of that bioclimatic zone. So we're having to change everything we're doing. Our whole design process is changing now to accomplish this. And Serge, I really want to thank you very, very much for that. Please help me give Serge a big